Okay, good morning, everybody, and welcome back to the Geo-Python course for now week number 5. I hope everyone can hear okay, and maybe I'll let Wolfel also test her microphone.
Yes, good morning, everybody. Can you hear me loud and clear?
Loud and clear. So as you can see here, we have our poll question open still. So if you're just kind of getting warmed up for class today, you're welcome to go to the poll site. You can see it here in the address bar for Wolko's window, and you can also find a link in chat for how to go and fill in your comments about thoughts related to week number 4. Just as a reminder, we talked about functions, script files, and modules during that lesson. So if you have any questions or concerns about that, you can feel free to put them here. There are a couple things already here, so maybe we can comment on those first as we're getting started, and then we can get into our contents for week number 5 after that. So there's a question here, or a comment, I suppose, about different ways for importing functions from a script file. And it's true, we did introduce a couple different ways that you can do that. Before running the checks, it was not that clear which one to use. So I suppose this pertains to the exercise when you're asked to import your functions from the script file in terms of which form you should be using, whether you want to do import temperature functions as TF, or if you want to import something from the temperature functions script file, you might want to do something like from temperature functions import var to Celsius. I don't recall actually, Volko, maybe do you remember which format we were expecting people to use? I don't know actually whether it matters. For the purpose of the exercise, I would have to check.
Yeah, well, yeah, first of all, it's a good point. We should maybe recommend one clear approach how to do it. Of course, it's good that you know different ways of importing, and in different situations, one might be better than the other. Out of the blue, maybe in the exercise, I think we were expecting to import function name from module name, but if you did it in different way, which is logical, that's completely fine. So I think especially at this point of the course, we're getting into the kind of point where there's like 10 different ways of doing things. Some are more readable than the others, some are more efficient than the others. And then we, of course, try to provide the best practices, but there's often many ways to do the same thing and get the same result equally efficiently. So, yeah.
And yeah, I think there's a couple other things here just that we can touch on. So yes, last week's exercise or the practice time was pretty short and straightforward. Someone would have liked to have had more problems to solve. This is a comment that we get from time to time. We also saw it in the midterm feedback that we collected, that there are people who would like some additional optional problems. And we have been trying, I think, for a few years now to find time that when we're preparing everything for class each week, that we would have time to create some additional problems. And we appreciate the comment. I think we can, perhaps we will, we have opposing views here about the extra problems as well. But as mentioned, we are working on this material for a textbook, and perhaps at that point we'll actually be able to devote a bit of time to making some extra problems, because I think it would be indeed helpful to have a bit of opportunity if you want to practice more, that we have some ready things to go. But yeah, time-wise, I think we're kind of limited at the moment in terms of being able to make extra problems for this year's version of the course. But that's a useful comment either way.
But this week's exercise has an additional extra optional problem, so
indeed it does.
Wait for it.
No. So okay, that's great. Thanks for the comments so far here. There's a question about when we're going to use GIS. I suppose that's mainly going to be starting in period number 2 for those who continue on to the Automating GIS Processes course. I don't know, Volko, if you have anything you want to comment about that.
Yeah, so indeed, teaching period 2 is focusing on the spatial methods using Python, but already today, as we start learning Pandas, that we'll talk more about in a bit, so that forms the basis of our GIS analysis. So when working with GIS data, it's often just tabular data. So today we will start interacting with actual data. So that's then good basis for the AutoGIS Part 2 course in next period.
Yes, so if there aren't any additional questions or thoughts here, perhaps we can move on. We have a bit of a busy lesson, I think, today in terms of introducing a number of new things, and so it's probably good that we keep moving a bit. And perhaps I can ask if I could share my screen, Woko. And let's see here. Oops, what just happened? Okay. Now I hope you're able to see my screen. And this is our overview for the lessons this week. We're going to be using a package called Pandas, and we will spend basically the entire lesson getting introduced to Pandas, and we'll start for the first time reading information in from data files and writing information to data files using this Pandas package. So up to this point, we've been working with things mainly in lists that were already populated or lists where you would type in some values. And now we're going to start interacting with data files. And this is really where I think the world of, or the sort of potential of Python starts to emerge. Because once you learn how to read in data files, all of a sudden you can use the same script to process tens, hundreds, even thousands of data files, and you begin to see how powerful Python is. Before we go to that, though, there is one thing I want to review here briefly, and I'm just going to refresh my window and hope that this does look like the updated course feedback. So first off, thanks for those who responded to the course feedback form up to this point. I think there are 28 responses we've received, and we appreciate every one of those. It's very useful for us to get direct information from you about how things are going. And as you know, there were a handful of questions here, and I thought maybe we could just go through briefly what the responses were. And these are just kind of consolidated common views among the respondents and a select view here and there about particular things raised by individuals as well. So in terms of the pace of the lessons, too fast, too slow, or about right, most people seem to think it was about right on average. For those who have more experience with coding, it's maybe a bit slow sometimes. And for those who are new, it's maybe a bit fast sometimes. And that's, I think, very similar to what we've seen in years past. One challenge that was brought up this year that seems to be specific to the online learning is that when you're working on your computer where perhaps you're wanting to monitor Zoom and then you're also wanting to follow along in the notebooks at the same time, it can be a bit hard to keep up when you're switching between tabs. And yeah, we understand that. That is something where we hope that you're able to just sort of listen and follow along as we're going through the notebooks, but we do realize that sometimes you do need to switch back and forth, especially when we deviate from the lesson materials that are online. It might be that you want to watch and see what we're doing. And yes, in a normal classroom, there would be a projector and you would see what we're doing up on the screen while looking at your laptop screen at the same time. And so we appreciate this is a little bit more challenging. If things get too fast, you can always say something in chat and ask us to slow down or repeat something. We're more than welcome to do that, or more than happy rather to do that. And one other comment that was mentioned here, just a specific thing, is that 3 hours is a long time for the lessons. Yes, we agree as well. And that there could be some material left out that's sort of optional things. This week's lesson, we do have a couple extra items in there, and so perhaps we will just mention them and then you can refer to the course page to read them over. I don't think we're going to come in short of 3 hours this week, but at least we can fulfill one of the suggestions here. I don't really know if it helps actually, but yeah. As Volko mentioned here in chat, if you didn't see it, one idea is that you could have Zoom open, for instance, on your smartphone, so you have a second screen, or if you have a tablet or something like that, you could have Zoom open there so that you can have your main computer available for doing, and then the other device there for following along. But yeah, we do appreciate that this is not the easiest learning situation. In terms of the content, compare overall, too simple, too difficult, or about right. It seems, again, to be about right for most people on average. And again, those with experience programming already might think things are feeling a bit simple. Perhaps this week will be a little bit more of a challenge because we're learning something that's more than likely new entirely to you. And that, yeah, again, some topics have been harder than others. There was one comment here that says the lessons are far too difficult due to poor teaching skills, which of course gets a frowny face from us. But if you have comments about things related to that, we are open to taking the feedback as well about if you have ideas about what we could do differently, how we could teach things differently that might improve the experience. We've been teaching the course for a number of years now, and we think that we've settled into a pretty good way to do it. But if you have comments about how things are being taught and how they could be improved that are specific, you're always welcome to give us that feedback. And we'd be, again, happy to try and incorporate it as best we can. Regarding the exercises, too simple, too difficult, about right. Again, it's about right for most people, and that's good to hear. I suspect that after this week and next week's exercises, perhaps you'll be leaning slightly to the difficult side of your feedback in terms of the exercise challenges, because again, week 5, 6, and 7 get a little bit more challenging. Not to scare you, but just to prepare you that you might need to spend just a little bit more time. And of course, this varies with the level of experience that those that are new to programming entirely find things more challenging. There was a request here in a few cases for extra problems, as already noted in the warm-up questions for today. So things like making the flag were fun problems. And again, we do have an extra problem for this week's exercise. So hopefully that's helpful in some way. The exercises are harder than the lesson material. There was a comment that was there as well. And yes, that's right. In essence, we want you to be able to take things from the exercises and, or from the lessons rather, and apply them in the exercises, but also to push yourself a little bit more in the exercises to perhaps go a little bit beyond what we covered in the lesson material. So we hope to provide the foundation, but also that you go a step beyond what we did in the lessons in many of the exercises. There was a couple, or at least one comment here about some things not being properly taught in the lessons. Again, I think all that we can say about this is if you have specific comments about things you find confusing in the lessons, please feel free to let us know. And would be easier to learn if the course infrastructure was clear. Yeah, I think this is, there's a lot of platforms between Zoom and GitHub and the course website and the CSC notebooks and Binder and many of these different things, Slack. And yeah, we appreciate that it can be hard to just maneuver between the different sites and keep track of what is where. Hopefully by this point in the course, you're starting to get a little bit more settled in and realize that there are reasons why we include these many different platforms, that they all contribute something. And yeah, we try to make things as simple as possible, but we still want to provide support and real life experience with tools that people are using who do this kind of thing, like coding in Python for their career. All right, so a few things about the course that were most helpful to you. Exercises, I think that's probably number one every year. Pair programming actually came up in a number of responses, which was really great to see because that's a new thing that we introduced and we had no idea how it would go. You might notice that it also appears in the least helpful aspects of the course list. So not everybody likes pair programming, which is understandable. Otherwise, having material online seems to be helpful. The lecture videos, if they were uploaded right after class, that would be great. And we try to get them up as soon as possible, but sometimes things are a little bit delayed. And working on real life tasks is something also that's helpful. And I think you'll feel the same way about that after this week. And things that are least helpful, Zoom exercise sessions. Jeff, I think it was the comments that came up mostly about the Zoom exercise sessions were just some people weren't using them, so they didn't think it was that helpful. And again, working in pairs for some people is not something that they enjoy. We will say something about that for the exercise this week. Not being able to save things with Binder. So there was at least one person who mentioned they were using Binder on their work computer to do things in the course, and were a bit frustrated they weren't able to save things in Binder, and asking if there were any solutions for that. I mean, you can download your notebooks to your own machine, and so it is possible then to, at least with Binder, there's an extension that allows you to basically save a notebook in your web browser and then re-upload it to Binder to continue working later. I guess if you're not able to work on the CSC notebooks, it wasn't clear from the response and the feedback whether that was true. But working in the CSC notebooks is probably the best place in terms of working. If you can't install Jupyter on your own computer, CSC notebooks would allow you to save what you're working on there. So that might be useful. And again, about the least helpful things, there's too many platforms, services, sites, and again, we've commented on that already, I suppose. A little bit about, oops, looks like I messed up the numbering here for the questions, but useful parts of the course. So there was these questions about scale of 1 to 5, how useful are different elements of the course. And here's just the kind of average values with the standard deviation. So interactive sessions in Zoom, 4.24, recorded lesson videos, 4.2. You can see basically here the values of the standard deviations and how many people responded. The only thing that really kind of dropped off a bit from what was expected was the pair programming was a little bit lower. So a value of 3 is sort of neutral. So on average, people found it a little bit better than neutral, but there was, as you can see from the standard deviation, quite a bit of variation in how people felt about the pair programming. And again, that's not really a big surprise because some people were commenting that they prefer to work independently. But anyway, you can see the numbers summarized there, and I don't see anything that really jumps out as alarming. So finally, some suggestions for improving the course, making pair programming optional. We are going to do that starting this week in the exercises. So that's good to have the feedback, and we were already thinking to do some things like that. So we'll talk about that when we get to the exercise. More detail in the exercise instructions. I mean, there's comments about this saying that the instructions are also too detailed. So we try to find a balance where we give enough of a description of what you should do, but we can look in some cases to see whether we can give a big picture overview of what you're going to be working on that might be helpful in cases where that's lacking. Otherwise, I don't really see anything else here that looks particularly urgent or different. There was one comment about it would be nice to know more about what you can do with Python. So maybe from the beginning of the course, I suppose it might be useful to have some better examples of different kinds of things that can be done with Python, and that's something that again we could consider in terms of the course motivation. And then there was one other comment here about including some time to start on the exercises during class. If we want to push it to 4 hours, we can do that. But unfortunately, our lessons as it is, we pretty much use the full 3-hour time, and I don't know how much we could trim out of there. So that's a good idea, because I do like the sort of thought that you continue right after you've just seen the material and start coding. But for right now, with the way we've formatted things, we've stuck to the 3-hour lessons. Finally, for the last thing about the general comments about the course, I just want to note there were many positive comments there about people enjoying the course, and so thank you very much from both myself, and I'm sure Woko feels the same way, that it's great to have your positive feedback and support. We would love to be able to sort of see your positive looking faces in an audience in a classroom, but it's nice to have the positive comments here regardless. And with that, I think maybe that covers our feedback. So Again, if you haven't yet filled in the feedback form, I don't know, Volko, it was earlier set to be like a timed form so that it would close at some point. Have you extended the time where people can give feedback?
I'll check it, but I'll keep it open until the end of the week, let's say so.
Yeah. So yeah, if you haven't given feedback, I mean, 28 people, we appreciate the 28 who've responded so far, but that is not the maybe a good representation of all of the people in the course. So we would be very happy if you still felt like it was useful to take the time and give us some additional feedback. Again, we appreciate every bit of what we hear from you. Okay, so now we are going to go perhaps to back to our lesson for today about pandas, and I suppose maybe Volko can give you a sort of quick introduction to what pandas is all about, and then we'll move to the first lesson piece. So I'll maybe stop sharing my screen.
Dave, you can keep your screen shared, I think. If you just open the pages, there's not much. Yeah. Sorry.
That's okay.
As it worked so well last week. Okay, so let's get started with today's lesson. So basics of data analysis interacting with actual data files is the topic of the last 3 weeks of the course. So we will introduce you to this library called Pandas, which is basically a data analysis library that combines several powerful tools for interacting with data, reading in files, writing output files, processing data, visualizing data. And then maybe as a motivation for those interested in the GIS topics, so then in the second teaching period, we will continue with GeoPandas. So as the name tells, then that will extend Pandas capabilities for analyzing geospatial data. So if you think that you have a spreadsheet, some rows and columns, we will now start working with some weather data, with some attributes. So then in the second teaching period, we will then add the actual coordinates and geometries and start analyzing those. So everything we do here now then forms the basis for the further data analysis and spatial data analysis. Maybe Dave could scroll down a bit. You can then read the text introduction to Pandas and who has developed it and so on. And just to sum up, we use Pandas for reading in mainly tabular data, so data which has some rows and columns, so kind of this two-dimensional array data. And we will use weather data as our example. And I would assume that most of those listening have at least used Excel for processing such data. So we might sometimes use these kind of Excel references for explaining how things are done. I guess that's the mainstream software for everybody when first time interacting with data. But these data can be stored. Well, we could work with Excel files, but mostly during this course, we will be reading CSV files. So data that has been where all the columns are delimited with a comma or some other character. But then Pandas can also be used to read and write various different file formats, regular text files, JSON, Stata files, which is another software for statistical analysis. And then Pandas or Python has also these own data compression file formats, such as the pickle format, which I have used in my own work quite a lot. And then Pandas can be used to interact with databases, for example, PostgreSQL, and also spatial databases, PostGIS, then later on with GeoPandas. So yeah, that's a quick summary to Pandas. Myself, for me, that's the main tool I use nowadays for processing any kind of data that I receive, be it in Excel, CSV, GeoPackage, shapefile. So Pandas and GeoPandas is the main reason I use Python, basically, then in addition to these ways of automating then the whole process. Yep. So I guess Dave will continue with the first part of the lesson. And just to sum up, we will now kind of move to the idea of data analysis workflows. We will have some input data. We will do some processing, and then we will produce some outputs. And then, of course, input data might be messy. We might need to modify that. Processing can have several steps. And then outputs, there can be one or several, and then we can automate this whole process at the end. So that's the main goal of the last part of this course. So Dave can continue with the first part of Pandas, reading in data and exploring data, and then I will continue from that after the break.
Yeah. Okay. Well, thanks for the introduction, Volko. And yes, as mentioned, we are going to continue now with our lesson using Pandas. And for that, I am going to go here to my CSC Notebooks instance. And if you haven't launched this already, you should go ahead and do that. And then you can go to the Notebooks L5 directory, where we are going to start with exploring data using Pandas. So you can open up that notebook to get started. And yeah, you should see something that looks like this. Hopefully, if you open it up, if you're having problems with not seeing the lesson 5 notebooks, Volko, I think, had earlier commented in chat about that particular issue. But one way to deal with it for the time being is you can always open this CSC instance for the Python Lite, Geo-Python Lite, where there is no persistent storage, so your notebooks won't be stored, but at least you can see them and work on them in the time we have for our lesson today. So yes, we're going to start into interacting with data files in Python now, and that interaction is going to begin with trying to understand, first off, what the format of the data is that we're going to read in, for instance, using the Pandas library. And Pandas has two kind of data structures that exist that we should make ourselves somewhat familiar with. We've seen other data structures. I mean, in essence, this is kind of a fancy name for a data type. And so we've seen Python lists, where you have a collection of different values in a list. We've seen other kinds of things, integers, floating point numbers, character strings, etc. With Pandas, we're going to be introduced to a structure called a data frame and one called a Pandas series. And for both of these, we have some examples here that show what the data look like when they are in one of these structures. And if we start over here on the left with the Pandas data frame, we can see here what a data file might look like. This is the first 10 lines of some data file that has 4 different columns in it. So you can see, for instance, here, column headings, temp, max, min, things that look familiar. Over here on the left side, you can see some numbers that start at 0 and go up to 9. Those are index values. Those might also look somewhat familiar, at least in terms of the idea. And when we print out something, for instance, if we print it out in the one of the Jupyter Lab Python cells, we printed out the first 10 lines of our data frame, we would see something that looks like this, and it looks very similar to the nicely formatted data over here. It's just that when you look at this in Jupyter notebooks, it recognizes it as a Pandas data frame and gives you this nice kind of a rich text formatted table instead of the plain text that you have here. The key things that you see is that we have rows starting at 0 going to 9. We have columns here with different headings. And this is essentially a 2-dimensional data structure that's like a data table or like a spreadsheet that you might be familiar with, for instance, from something like Excel. The Pandas series is very similar, except for it is a 1-dimensional structure. So you can think of it as being like a single column out of a data frame. In fact, if you take a single column out of a data frame, it is a Pandas series. So you'll see the same kind of things here, that you have your values. You can see an index value as well here. There's a name for this data series. It's temp. and it contains all the same values we saw in the temp column in the data frame that we had before. And you can see, for instance, here also when you print out the series temp, that the values are stored as a floating point values. This is the data type, or D type, float 64, which means a floating point value with 64-bit precision. We can see a little bit more here if we just scroll down to our annotated version of what we were just looking at. And many of the things that I was mentioning already are just labeled here. So if you want to kind of remember what is where in a Pandas data frame, or what index versus data versus column labeled, Pandas series, whatever, you can perhaps refer back to the lesson here and take a look at these diagrams just to illustrate what a data frame contains. The main thing here is that this is a little bit more of a high-level representation of the data than we saw before. The Python list was a fairly simple structure. It could contain, any number of values in a collection, but it was sort of a little bit less complex than something like a data frame, where in a single data frame, you can have multiple columns, multiple rows, different index values that don't even necessarily need to be numbers starting at 0 and going up. We'll see some examples of that. But this structure is basically what we're going to be working with when we start interacting with things in Pandas. So if we scroll down just a little bit further, we want to note two things here. One is that there is a book by Wes McKinney, who was the main developer for Pandas. So Python for Data Analysis is a book. You can find more information about it on the course page if you click this link. That gives a kind of comprehensive overview of interacting with data in Pandas if you're interested. And Pandas, of course, also has online documentation that you can go if you click this link, for instance, here, and find all kinds of information about Pandas, including this nice lesson about their introduction to their data structures, and many, many more things available there in the user guide for Pandas. All right, so you can also read a little bit more information here about what might be underlying and what's running in the background that Pandas is taking advantage of here on the course page. So as Volko mentioned, we are working with weather data in our lesson for today. That's going to be the case for a number of the lessons going forward from here, because weather data is something we're all roughly familiar with, and perhaps also something that that we can agree between the geologists and geographers that we can perhaps have some common overlap and interest. Volko, there's one comment here in chat about the lesson 5 notebook not showing up. Maybe you can assist with that. But yeah, we have a data file here. It's in this case called Kumpula June 2016 with metadata.txt. And you can click on the file if you like, and you'll be able to see what the data file actually looks like. It's just a text file, and you can see there's comma separated values in here, and a heading at the top as well. And this will be what we're going to be working with in our exercise for today. We'll be reading in that data file and interacting with the data that contains it. The data file itself has observed daily average, minimum, and maximum temperatures from 2016 in June from the Kumpula weather station in Helsinki. And there are 30 rows of data in this sample data set. That's because there's 30 days in the month of June. And it's been derived from a data file of daily temperature measurements available from the National Oceanographic and Atmospheric Association in the US NOAA, and you can go there if you're interested to try and find more data files. We just cropped out a little bit of data from the NOAA data file we downloaded just to have something to work with. All right, so that's our data. Now, let's get started with using pandas. And as usual, if we're going to use a library in Python, the first thing we need to do is import that library. So we can do our import of pandas as PD. So that's the kind of customary abbreviation for pandas when you import it, that you can import as PD, and then you can do Shift Enter to run that cell, and the pandas library should be now imported. First thing we're going to do is read in our data to a variable called data. So we're going to read our data file using a function in pandas called read_csv. So we can do pd.read_csv, stands for comma separated values, which is a very common data file format to use. And then we give the name of our file. So in this case, it's Kumpula. And I think if you press the tab key as you start typing in the file name, the Jupyter Notebook will recognize that this is the name of a file, and it should auto-complete the rest of the name of the file for you. So if you just press the tab key after you started typing in the Kumpula in the quotation marks, it should automatically fill in the rest of the file. And you can see over here in our little file browser that that is the name of the data file we're working with. So with that typed in, I can now press Shift Enter, and we don't necessarily see any output here, but the data file has now been read into this variable called data. And we can take a look at that in just a second. There are a couple notes here about some optional things you can pass to the read_csv function when you read things in. One of the common things you might pass is this parameter called sep that's used to designate the character that is separating the columns in your data file. We're using comma separated values, as you could see in our data file here. If we just go back briefly, you can see that for each value, we have some number and then a comma, and then some number and then a comma, and then some number. That's the default in the read_csv function in Pandas, is it will assume you're using commas because comma separated value data file, that seems like a logical thing to assume. If that is not the case, so if there was some other delimiter like a semicolon, you can then use sep to specify the semicolon as the delimiter in the data file. And I think, as Woko already mentioned in the introduction to Pandas, there are a lot of different file formats you can read with Pandas. Read_csv is just one for using text files with commas, spaces, or other common separators, but Pandas can also read Excel and Python pickle formats and other things, and you can find some more information about that at the links that are given here. But let's go back now to see what we have in our data file, and I'm just going to type in data and press enter, shift enter rather, and I get some output here that looks kind of nice. I have something that looks like a table, but I also have some weird things here at the top. And if I print out my data file, if I just do print data instead, it's actually maybe even a bit easier to read. And yeah, we have some issues here. This doesn't look like what we were expecting. For instance, here, if we're looking in some of these columns, that should be things like minimum or maximum temperature. There's some things like NaN in here, and things don't quite look right here. First off, the NaN characters, those are designating things that are identified as not a number. So this is kind of a no data value in the data file. And there's a bunch of them at the top. And we expected also that we would have 30 lines of data, but we have 36 here as the index, and it starts at 0, so we actually have 37 lines of data. So again, things are not quite adding up here in our data file. And as it turns out, when we go back to looking at the data file that we had open before, the first 8 lines are actually a kind of a header that we don't really want to read in as data. This header is telling us some information. This is metadata basically about our data file. Useful stuff. Really nice that the data source is listed here, so we can go and get the original data if we wanted to. and then what's happened in the file while we extracted this raw data file and converted it to a comma separated format. So we've listed here what's already happened in terms of processing the data. But we don't want to read any of these first 8 lines because they're not the data we want to interact with. And so what we need to do is we need to skip over this header when we read in our data file. Let's try again. So again, we'll take our variable data, and now we'll do pd.read CSV. Again, we've got to give the file name, which is the Kumpula, and I'm just going to hit tab again to auto-complete the file name here so I don't have to type all of this in. And now we're going to add an extra parameter here called skip rows. And the skip rows parameter, when you give it a number, will skip over that number of lines at the start of the file and then read the data in from that point. So I'm just going to press Shift Enter. This will overwrite what we had stored in data previously. And now if we print out what we have in data, or just type in data and press Shift Enter, now we get something that looks a little bit nicer. Here we can see the expected column headings that we have. This year MODA, in case you haven't figured this out yet, this is the year, month, and day of the observation that was made here. So 2016, June 1st. And then we have a temperature, a max, and a min. And these temperatures are given in Fahrenheit because this data is from the National Oceanographic and Atmospheric Association database, where often the data are stored in Fahrenheit for temperature. We will deal with that when we come to it. But we also notice here that we now have index going from 0 to 29, which means we have 30 rows of data and things are looking better. We still have these NaN values here in some places, but these are actually cases in the data file where there is missing data, and those NaN values are representing exactly that missing data. So that looks good. Now, in this case, we've read in a pretty small data file. If we had read in a data file that had 200,000 lines of data, perhaps we don't want to look at the entire thing by printing out what's in data. But instead, we can use a handy thing here, a function called data.head. So since data is a Pandas data frame object, we'll see that in just a second, but this variable data is a data frame. There are some functions that operate on data frames, such as this .head function, which gives you the first 5 lines of the data in your data frame. That can be quite nice if you just want to quickly check and say, how do things look? Okay, cool. Looks like the formatting is as expected, and then you can move forward. Alternatively, you can do data.tail. And if you run this, data.tail just gives you the last 5 lines of the data file. So head is the first 5, tail is the last 5 by default. Of course, you can put in numbers here if you want to get only the first 7 values. You can put a number in here for the head function, and that'll give you the first 7, or if you wanted 17, whatever you want, you can put in some number here. Whatever number you give will give you that many rows of data out of your file. But if you give nothing, it gives you simply the first 5. And same thing goes for tail. You can put a number in there if you would like. Now, we should note that our data frame has labeled axes. So we have rows and columns that have labels. And we can already see that we have our index values here in bold, and you can see them showing up, indicating that they are an index and not a sort of value that's part of the data here, directly at least. And we have then our column headings, as you can see, year, MODA, temp, max, and min. And we will learn how to use some of those headings, for instance, to select data at a little bit later point in the lesson here. Now, one thing we can just do to confirm that we are indeed working with a data frame at this point is we can use our familiar type function. Remember, this will help you identify what data type the variable is that you have listed in here. And if I run that, I see here that the data type is a pandas.core.frame.dataframe. So that is our data type that we're using is indeed a Pandas data frame, not a surprise in this case. Okay, so we've just seen how to read in a data file using this Pandas read CSV file function, and now it's your chance to try and test something else out on your own. So we're going to ask you in this case to read in our data file once again to a variable called temp data. And in this case, we want you to read it in, but only read in the column year MODA and temp. So in other words, our temp data variable should have 30 rows, just like we did before, but only 2 columns, year MODA and temp. And you can do this using the use calls parameter. And in the cell that's, or the cells that are here below, we'd ask you to try and do that. And when you've got that figured out, you can put a little green check mark next to your name by clicking on the participants list, and then in the participants list, clicking on the yes green check mark icon thing. If you need help about how to use this use calls parameter, you can click on the Pandas, this link here to take you to the Pandas read CSV documentation where that is described how to use that parameter. So we'll wait just a few minutes while you test out reading in your data to this temp data variable, and then we'll continue from there. All right, well, I think we should probably continue here. So for those who are still working, I apologize. I'll try not to compromise your efforts here too much, but I will show how we can read in this data file and only use certain columns. First, I just click here to the Pandas documentation, and you can see here the description of the Pandas read CSV function, and there's quite a number of different parameters that you can specify with this function. As you could well imagine, there's lots of different things you might want to do when reading in your data file. We've already seen, for instance, sep, where we can specify what the delimiter is between the columns, and we've seen skip rows. Here is our use calls parameter, and it says we should provide something list-like or callable. So use calls is expecting that we give a single value as, for instance, a Python list. All right, that's good to know. So let's read in our temp data here, again, using pd.read CSV, our same data file. I'm just going to hit, again, the tab key once I start typing in the file name to auto-complete that. We again have to skip our first 8 rows. So we'll say skip rows equals 8, just as we did before. And now we give our use calls parameter. And here, again, it's expecting something like a Python list. And since these are headings, and I'm typing this into the wrong spot, so I'm just going to cut that and put it up here where it belongs. Since these are headings that are character strings, we should be giving these values in quotation marks. So year, MODA, comma, and temp. So this will read in this data file here, skip the first 8 rows in the header, and only then use out of what it reads in the columns year, MODA, and temp. So if I run this, I don't see any output, but if I print out temp data and run the cell here, I now see the expected output where we have our 2 columns, year, MODA, and temp, and our 30 rows as we had before. So yeah, that's just a quick example of how to do that, because there will be cases you'll see, in fact, in the exercise this week, where you have a data file with many columns and you only want a few of them, and this use calls parameter is quite useful in just immediately skimming away all these things that you don't want to deal with at all. Okay, so now let's take a look at a few of the properties of our Pandas data frame. First off, we have, just like we did with the Python list, the possibility to use a function called len if we want to see how many rows of data we have in our data file. In our case, we already know that our data frame, has 30 rows, and sure enough, that checks out because we've already seen from the index values that we had 30 rows earlier. But if you had a data file with many, many more rows, using the len function is a useful way to get this information quickly and easily. There's also something built into a Pandas data frame, an attribute called shape. Now, an attribute is something that it's basically like a variable that's defined related to this data frame. So we don't have to include parentheses after this. This is just the name essentially of a variable that contains the number of rows and number of columns in our data frame. And when the data frame is created, this is automatically filled in for us. And we can see here that we have 30 rows and 4 columns in our data frame. Again, that checks out. Shape is only one of many different attributes that can be found related to Pandas data frame. So you can go here to this link if you're interested to see some of the others. Now, we have seen, for instance, already that we have data.head, for instance, to give us our values for the first 5 rows. But we can also, if we want to know just the names of the columns, do something like look at our data.columns.values. So data.columns, maybe I'll show that just first, will give us the names of our column headings. So year, moda, temp, max, and min. In this case, it comes in the form of an index object. But if you do data.columns.values, again, columns is something that's known as an attribute for the data. .values will then just return this as a simple, this is actually a NumPy array, but it's more or less like a Python list. And you can see it looks a bit like a Python list in terms of what is shown here. We aren't going to deal with NumPy directly in this course, but it's a library that's used in the background in Pandas, and that is why this column .values comes back as an array of values. If we want to see the index, we can also print that out or just type in data.index and run the cell. Got to spell it correctly. And you can see here in this case that we have what's called a range index starting at 0, stopping at 30 with a step of 1. This looks a lot like if we were to do something like use the range function, and we said that we want to have 30 in our range. We have basically a range 0, starting at 0, stopping at 30, and the step of 1. We could just explicitly put that in if we wanted to and get back the same output that we have there. So this is a lot like our range function we had seen before. And here it's just telling us we're using an integer range with our starting, stopping value, and step. And remember that stop is not included in the range index. So that's why it goes from 0 up to 29, as we saw earlier. So we've seen a little bit about how we can see the size of our data frame, how we can tell what values are in the different columns and things like that. But we haven't yet seen how we can check to see what kind of data we have in our data frame. And for that, we use a function, or an attribute rather, called data.dtypes. And if you run this data.dtypes, it tells you for each one of the columns what kind of data is stored for that column. So you can see, for instance, that year moda is an integer with 64-bit precision, while the other 3 columns are floating point numbers or decimal values with 64-bit precision. And if we scroll back up to the last time we saw our data frame, we can easily see year moda is made of whole number values, no decimals here, whereas other things, we scroll even further back up here, we can see the other temperatures are floating point or decimal values. So again, that makes sense. Okay. So here we are at another opportunity to check your understanding. I'm going, oops, looks like Volko has already cleared away the check marks, so thanks for being proactive. Here, your task is to see if you can find out a way to print out the number of columns in your data frame. And we're not going to give you any hints. You can just see if you can come up with some way that you can think of to print out the number of columns in data frame. And once you've figured that out, you can put a green check mark in the participants list, and we'll continue when we get about half or maybe a little bit more of the responses there. Okay, so we're getting not quite half so far, but maybe this is a sufficient number. There we go. We're getting a few more. Sufficient number that we can continue here. So yeah, if we want to print out how many columns we have in our data frame, we have to think about, first off, how do we figure out how many columns we have? And there's actually a few different ways we can do it, but we've already seen that we can do things like, like data.columns. And we run that, we get back this index thing, and you can see there's a number of items there. You can also do data.columns.values, as we saw before, to get the array of the names of the different columns. And if we simply do the len, or use the len function with that, then we get back very easily our number of columns that we have. You could also just do len of data.columns, as we saw before. And I think you could possibly also try to use data.shape, since we saw that that gave us back two values. If we know the second one is our column value, you can also do data.shape with the index for item number 2 that attribute returns. So the first thing is rows, second thing is columns. So data.shape with a 1 there for the index will also give you the number of columns. So there's a number of possibilities here for how to do this. All right, let's now move on to selecting some values out of our data frame. So if we want to take specific columns, for instance, out of our data frame, we can do that, and we can make a new variable here called selection. So selection is our new variable where we are going to store only the year, month, and date and temp values from our data frame. The way that we do this is we take our data frame name, then we put a square bracket, and then within the square brackets, we put a Python list to indicate which columns we want to use. So we should be using year, mo, da, and temp. The reason that there's two sets of square brackets here is that the first one is to indicate that we want to take something out of our data frame. And the second is the single object, or the single kind of, I guess, yeah, you could think of it as a Python object. This list is our one value that we're going to use to get our two columns. So these two column names are combined in a single list, and in that way, it looks like we're just taking one thing out of our data frame. If you don't include the second set of brackets, I don't think this is going to work. You get some kind of key errors here that it complains, and so you need to have two sets of brackets in this case so that the list of things you want to have for the list of columns is enclosed in square brackets. So that's our selection. I just run that cell by doing Shift-Enter. And if we just type in the name of the variable and press Shift-Enter here, you can see the values that we have selected out of our data frame are the two columns that we expected. And again, our 30 rows of data. If we check the data type, again, using this type function, just do type with selection, we again see that this data frame is our data type. And that's true. If you take a piece of a data frame like we've done here, select out some columns, excuse me, some columns from the data frame, you indeed get a Pandas data frame as the object that comes back. Okay. Again, we can explore some things about our selection if we'd like to. We want to know how big it is. We could do selection.shape as we did earlier. Should get 30 rows, 2 columns, and we get 30 rows, 2 columns. We can also take a single column out of our data frame rather than selecting multiples. And if we did that, we say we want just 1 column out of here. When we do this, we only need to use 1 set of square brackets because we're listing just a single column here, not a list of columns. And if we do data within our square brackets, the name of the column temp, and run this, you can see here the output looks like this. Looks similar to what we saw before, but not exactly the same. You can see the index values on the left, the values of the temperature themselves in there on the right. And if we check the type here, so we can just do type, and we'll just do what we did before, which is data temp. So this is the command we just ran. We check the type of this, and we actually get back that this is a different kind of data, at least a different kind of object in Pandas here called the Pandas series. So that, again, this is for a single column of data that we call that a series in Pandas nomenclature. And that is our 1D data structure. There's a note here that just says you can also choose this kind of like shorthand syntax with Pandas for certain kinds of variable names. You can actually type, instead of data and then putting in the brackets here and the quotation marks, temp, we can also get the same thing by just doing data.temp, where we type in the name of the variable here, and that will give us the same thing back that we just saw. But that doesn't always work. If you have column headings that have spaces in them or other characters that are not allowed in the name of a Python variable, then this format won't work. So for our purposes, we recommend that you always use the name of the variable, or name of the data frame rather, and then the square brackets, quotation marks, and column heading names inside the quotation marks. That's the safer way and more consistent way to do things. Okay, so a couple last things before we take our break. It is about that time. But just so that you know, there are some ways we can get some basic statistical information straight out of our data frame and very easily. So we can do things like, for a given column, calculate what the mean value is for the data in that column. So if we go back to our temp column here, we can take our data temp.mean, and that will calculate the average value of the temperatures in that column, which comes back here as 59.73. And looking at the data we saw before, that looks roughly about right. We can also check the mean for all of the columns in our data frame by doing data.mean. So here we're not listing the name of the column, but just doing data.mean. And when I run that, then you can see here the name of the column and then the average value for each of the 4 columns in our data file. That's handy. And that's even gets better with Pandas, that you can do data.describe. And that is a function, and it does a bunch of different kinds of things here that are basic statistical calculations. So here we have our 4 columns, and for each column we have count, which is the number of values in that column. And you can see, for instance, we have 30 temperature values, but only 27 max and 28 min, which indicates we have NaN values in there, missing values. We've got the mean, we've got standard deviation, minimum value for that column, and then the different quartiles, 25, 50, and 75%, as well as the maximum value in that column. So that's cool. There is another opportunity here to check your understanding. I think we will lump this into the break time, so I'll come back to that in just a second. But while we're here, I just want to show you one other thing. Since we're already reading in a data file and we can do it so easily, we can also plot our data using Pandas directly. So Pandas has some built-in plotting options. We will later explore this in more detail in lesson number 7. And this stuff all relies on a library called matplotlib, which we'll also hear a little bit more about in lesson number 7. But for right now, there is a .plot function that you can use in Pandas. So if you have data, here we have a selection of columns, so temp, max, and min. And if we just add .plot to the end of our data frame, we can very easily get a simple little plot like this, where you can see how the maximum temperature, mean, or temp, and the minimum temperature all vary from the start to the end of June. Now, probably you want to start making this pretty, adding in axis labels and things like that, but we're going to get to that when we get to lesson number 7 and start talking about plotting in more detail. There's a question, it looks like, in chat about making a histogram. I don't think that's something that we will cover, for instance, in today's lesson, but we can perhaps put a link or something if you're curious about how to do plotting histograms using Pandas. We might be able to give you some assistance on that, but I think we won't go into detail about how to do that today, just to kind of stay focused on what we're being introduced to. Last thing that's here in the lesson is this: how to go from a Python list to a Pandas object. So basically how to make a data frame or make a data series out of some Python lists. So this is extra stuff that you can just read through if you're interested in the idea, but essentially it is of course possible to make a data frame using Python lists. So we could take some of the data, for instance, like what we dealt with in the earlier exercises with these weather station, latitude, longitude, things like that, and make a data frame containing that values, those sets of values, relatively easily using Pandas. But yes, at this point it is 10:31, and it is definitely time for us to take a little break. What I'm going to suggest is we'll tack on a couple minutes to the break time. So perhaps we can come back at, let's say, 10:45. I hope that doesn't cut Volko's time too short. But in the time, you can take a break, and you can also do this check your understanding question here and put your green check marks once you've got an answer. But here, what you want to do is take our describe function and use that only for the columns temp, max, and min, not including the year mode, because year mode doesn't really make any sense when we are dealing with the data that we have here, which treats year mode as if it's a numerical value when actually it's a date. So exclude that one, and you can run the describe function again to get your statistics for only the temp, max, and min columns. And we will come back and continue at 10:45.